All right. Hello, everyone, and welcome back to SOLIDWORKS Live Design. If you're joining us for the first time, SOLIDWORKS Live Design is a series that we run here at SOLIDWORKS, and it's all dedicated to the pursuit of learning from one another. And this season is all about deep dive topics. So we're diving into topics that are near and dear to the presenter's heart, and they'll be sharing their expertise, their knowledge, and we get a front row seat to it all. My name is Noah Zeef, and today we're joined by someone who's going to answer the age-old question, what happens inside of a Pokeball? And that's Carlos Reyes from the channel Carlos 3D. Carlos, welcome to the channel. We're so excited to have you here.
Hello, Noah. Hi, everyone. Thank you for having me and for inviting me. And I'm pretty excited to share this project with you all.
Yeah, we're super excited to talk about it. There's a ton to get to. Before we do that, can you just tell us a bit about yourself and the channel that you run on YouTube?
Yeah, thank you. My name is Carlos, as you all can see. I'm a Mexican, but I'm living in France since 2016. So almost 10 years ago that I moved from Mexico to France. I'm a electromechanical engineer, and I have more than 15 years experience, I will say, on SolidWorks. So yeah, SolidWorks, I've been using it since high school, something like that, and I just love it. So yeah, I'm a content creator right now. I do content in Spanish, English, and French, and I'm just love creating stuff, colorful stuff, and some pop culture stuff from my childhood. So that's I love to consider myself as a maker and a problem solver.
Definitely. And I think the audience would fully agree with all those words you've used to describe yourself. We've seen you on the channel before, designing some crazy projects. I see the Iron Man suit behind you that we got to see. Love that one. And today we're going to talk about this giant Pokeball you made, right?
Yeah, pretty excited about that. It was a huge project. As you can see, it is huge. And also it had a lot of challenge, but it was a very interesting one that I would love to share with all of you, because SolidWorks saved me a lot of times and a lot of non-expected expenses. So
Right.
let's discover all together.
Let's do it. Let's jump in. Let's hear all about it. And to the chat, if you have any questions for Carlos as we're going through this, throw them in there and we'll be sure to get to them.
So let me start. I prepared this with this part, because the first question that I had about this project, well, let's rewind a little bit, and let me explain you why I choose to create a giant Pokeball. So the thing is that when I was young, I always remember seeing the Pokemon go inside the Pokeball, right? And I always wonder, like, what happens inside a Pokeball? There is a lot of theories, and people doesn't really know what happened. And even on the cartoons, they didn't explain that. So that's why today that I'm a grown-up engineer and that I have some new technologies as 3D printing, CNC, and SolidWorks, I say to myself, well, let's build a giant Pokeball for humans. I mean, it's a sphere, right? How bad or complicated will be. That's the intro to explain a little bit more about the design. So I just went for the SolidWorks. Let me explain a little bit more. Here we have it. So everything started with this part, because as I said, the first question was like, how am I going to build a giant sphere, right? At the beginning was like, giant sphere, easy, because just designing a sphere in SolidWorks, just do revolution, right? And that's it. But
yeah, in theory, it doesn't sound crazy complex.
Exactly, right?
Yeah.
Like when you say, like, okay, he built a giant sphere, easy.
Yeah.
But the
I'm thinking
complexity
like a
here
half
is
moon, or sorry, half circle, and then just revolve it around, right?
exactly. So, but that on the real world doesn't translate so easily. So I was just trying to visualize what it would be. So we have this part that is called the banana. I call the the banana, right? Because it's like
It's a good
a
name.
banana shape. And I thought about 3D printing because I'm pretty much familiarized with 3D printing. But when it's a big build like this, I said like maybe something different. So I went for a 15 millimeters plywood. This is around half an inch, I think.
Mm-hmm.
And I created this. This was the first part because I will just show you a little bit more. Once that I designed this banana, I just went for a circular pattern, and we had something that looks like kind of a sphere.
Yeah, definitely.
So yeah,
And
sorry.
did you go about CNC cutting these parts? I know you thought about 3D printing because you have a lot of experience there, but I'm assuming these things are way too big to 3D print. Is that right?
Yeah, exactly. And the first part is like, I don't have any big CNC machine, but then again, I think if you have the maker spirit, there is no limits. And when you have an idea and you're committed to do it, it's like, I will find a way, and I will just call some companies that they have like big CNC. And I just remember calling a couple of them, and I was like, hey, I have a project that is a giant pokeball, and I need to CNC cut this plywood. And they were like, are you kidding? Like, it's a joke, right? So fortunately enough, here in France, I just found the company that they were like, yeah, I know you. You are the YouTube guy that makes some crazy stuff. So why not? But before to going to this CNC machining, because I knew that it will not be so cheap, I just create a small version, a scale version of this build with the laser cutter that I have at home. This is very important, and I really recommend if you are going to do this kind of projects to do a small version of the build, because like that you can save money, save time, and also like just improve your design and think about the future. Because if the small part doesn't work well, when it's going to be big enough, it will be a nightmare to build. As you can see, this was a good exercise. Then we have the CNC part, and I will show you a little bit what happened next. So we have this sphere. I just use mirror, and that's it. I just at the beginning I was like just trying to do a sphere kind of thing. To be honest, I was not thinking about covering, because for me it was easy. I will just apply some MDF sheet, but we will talk about that later. But yeah, this was the first step or the first phase of the project. I don't know if you have any questions before going
Yeah.
to the next phase.
Well, first off, I really like how you went about the prototyping phase. So it looked like you 3D printed a smaller scale of this giant Pokeball. And when you went, yeah, oh, there it is. So when you went about doing that, I'd imagine the clearances for 3D printing those parts and combining them would be quite different from when you actually CNC'd them full size. Did you have to convert those clearances over?
Well, the thing was more complicated than that, and for me it's the exciting part, because you can calculate everything, right? But materials doesn't behave the same way. I will say like the wood is not so exactly like the 3D printed part. Today the 3D printers are really reliable, they are precise, but the wood, you don't have the same what to say, that the thickness or the same behave with different temperatures and kind of that, and
Yeah.
those sizes. I have like millimeters of tolerances, and they went away. Everything was like not quite reliable, but not from my design, because of the real world. And this is what I love about this project, is that I use my hands when something was not working. That's the maker spirit, I think.
Yeah, I fully agree. I love the maker spirit. I love how it came about as well. You couldn't find the answer to the question, what happens inside of a Pokeball? So you just answered it yourself. And along the
Exactly.
way, it sounds like you had some amazing maker challenges to solve. You showed a lot of, or you started to show some of the video of you actually putting together, getting the CNC manufactured. I do just want to shout out your channel quick, Carlos 3D, for anyone who wants to see um, the full video of you cutting, assembling, painting, and ultimately using this project. So definitely be sure to check out that channel if you haven't already.
Yes, please. Thank you about that.
Yeah, that looks so
Yeah,
cool.
because also I just began a new channel, because I was doing content on French, but a lot of people were asking about an English content. So I just decided to open a new channel this year that is called Carlos 3D World, and you can check the projects over there. It is not AI, by the way. People think like, how do you make like the same video 3 times? And the secret is like, I just put the camera and I speak 3 language, and I just record 3 different videos, and the editing do the magic. So I'm pretty excited about this new adventure.
I love that. Did anyone ever think the giant Pokeball was AI?
Yeah, a lot of
They
people.
did.
By the way, yeah. It's funny, because when I post it on Facebook or Reddit or things like that, a lot of people were like, "No way, this is AI."
Right. It's
And
almost not believable.
exactly,
But you had to prove to them, I really made this with my bare hands.
exactly. Like, go see the video, right? But
Right.
I'm okay. It's kind of complicated to think like a
Sure.
35 years old man fabricating a giant Pokeball. But
Never
why
too
not?
old, never too old to make a giant Pokeball.
Exactly,
So
exactly.
you made the frame, you made the plywood. What was the next step in making this?
Great. So this was the hardest part of the project, because as you can see here, people always ask me like, how much did you take to build this giant Pokeball? And to be honest, the design, I finished it in 1 week, something like that. The small version as well, the laser cutter. And then CNC was like one afternoon. And the next day, I just assembled everything, because I tried, and this is very important, and I will want to share with all of you that are interested in this kind of projects. And this is important of 3D modeling and thinking before manufacturing, is that I want everything to be as easy as possible to assemble, right? So I will
Right.
just hide this one, because as you can see, I just designed some groups, some kind of guides of assembly. Like that, I can just easy my work at the workshop. So this saved me a lot of time, and it took me like 2 days to assemble the sphere. So I was pretty excited, because it was like 1 week and a half to have this giant sphere. But I will just share with you what cost me around 1 month and a half to
Oh,
solve.
wow.
And this was the problem about covering the whole structure. So at first I thought about MDF, right? MDF, not so thick one, but when I put it on the structure, as you can see on the image, it was not round. After that, I was like kind of a IKEA solution, put another material between the structure, the wood structure. This didn't work, because sphere is more complicated than it seems. Uh, who would have thought, right? Like
Yeah.
in a sphere, it's complicated, but there's a lot of math involved on this project, because as you can see here, we have like a different angles. You have like a 3D sketch kind of
Right.
situation, and it begins to be very complicated. So in order to smooth the surface and have like an outer shell, I tried, as you saw, the MDF solution. Then we tried with another material. It didn't work. I was cutting and just trying to find a solution with my hands. And I was like, why am I doing this the old way, right? Why am I just doing everything by hand if we have 3D printers, if we have SolidWorks, we have CAD design? So I came up with an idea very late on the process, that was to design a auto shell. And as you can see on the screen, the auto shell, I 3D printed the auto shell. There were around 400 parts on this build. I don't have a big 3D printer, but that didn't stop me to do this. So the biggest one that I have is a Prusa XL, and I just put a 0.8 millimeters nozzle, and this helped me a lot with time. I was printing very big parts, and also I was printing some jigs, some fixtures to drill some holes and to create all this project. I mean, 3D printing can be useful for construction, but also it can be useful to make some custom tools. As you can see here, we have the drill as well. I just 3D printed propeller to mix everything pretty well.
Oh, I didn't even realize the propeller you used to mix the resin was also 3D printed.
Exactly, yeah, because it was late night. I think it was a Sunday, something like that. And here in France, Sundays, everything's closed. And we were like, we need to put the resin because it takes like 2 days to really dry. And we need to mix very well the components of the resin. So anyway, we just thought like, we will do it by hand. And then again, it was like, no, let's just make a propeller and just 3D print it. And in 1 hour, it was ready. So
That's amazing. And it looks like a lot of these parts are still quite large. It looks like you cut them down, into pieces that would fit on your build plate, but still pretty large. Did you have any warping that you had to worry about when you were printing these giant parts?
exactly. Let me just, we will isolate this. So this is what it saved me a lot of time. As you can see, I was thinking about 3D printing the outer shell, but when I saw that it was so big, I used one tool that it saves me was the split tool. Split tool allowed me to cut like different levels of this part, and I use the split tool with different heights. As like that, I can just import it on my Prusa slicer. I will show you real quick what it's like. Just give me 1 second. There we go. So this is what it looks like on the print. It's pretty big, but
Yeah.
the important thing, and I don't know if people use this enough, and I want to share what I use when I'm doing this kind of big builds, is that I export the step file. And the step file, it allows you to right click, and like that you can split two objects. And like that,
So you exported the piece as one from SolidWorks,
exactly,
and then actually split it in the slicing software.
Exactly, but as a step file.
But as a step file.
Yeah, exactly. You can do it on 3MF or another, but yeah, as you can see.
And that's interesting though, because a lot of times when it comes to 3D printing, we're using STL, we're using 3MF, maybe even sometimes OBJ. Why did you decide to go with step file?
For me, it's faster, and you can just export a lot of information on the step files, and you don't lose any resolution as STL when you export it on STL. At the end of the day, I'm going to send it, right, and just cover it with paint and things like that. But I'm just used to work with the step files, and a lot of people say to me like, yeah, but the step files doesn't work with Slicer, but it does work. And as you can see, it can save you time. Like this, you can put your parts, and also one trick that I used, I will show you real quick, is where's my there we go. We use text.
I see.
And as
And
you can see here, I just count the level, and I put like 6A, and the other part will be 6B. And this is very important because trust me, when you are working with 400 parts, with, I don't know, I used like 10 different 3D printers. At the end of the day, you need to be sure which part it's which, right? And
I was going to ask how many parts you printed. Is that right? 400 parts?
Yeah, exactly. Around 400 parts.
That's incredible. And that's a lot of material too. I imagine it's kind of expensive. We had a question in the chat about how much money did you spend to make it? You don't have to give us an exact figure, but was it more than you were expecting?
Yeah, way more. I have the number roughly. We can maybe let the people participate a little bit with this. I love this kind of discussion and
That's
challenge.
a great point. Yeah, let us know in the chat how much you think Carlos spent to make this incredible creation.
Let's do that. Yeah, great.
So 400 pieces. How many grams of filament did it take? How many rolls of filament?
Around 20 spools, or
20 spools.
Yeah, we will say it's 20 spools, because this was a big challenge, and even I just tried to design as a small thickness, but even with that, I had like some problems with printers, because it happens when you are running a lot of printers and a lot of print jobs. And also I just forget sometimes that it was printing the same part, so it was rough to follow up about this production, but it was a good solution, because as you can see, it was just perfect. The round shape was just following the wood, and like that we had like a good base to come to put some fiberglass and resin. But this is the next phase of the job. I don't know if people have some question about it.
Well, it looks like we're getting some guesses as to how much you spent on it. We have $2,000, $4,000. Maybe we'll let a couple more guesses in the chat, but we do have a question: how much scrap it takes? Did you have a lot of extra material when you're going through this?
Not so much. I'm very proud of it, because I'm trying to be mindful about the scrap. I'm not that kind of guy that because again, I don't want to make a lot of scrap, a lot of waste, but scrap equals to money that will not that will go out of my pocket and will never come back, right? So I'm just trying to do as much as possible. My CAD design, study everything, maybe make 2 or 3 parts of test part with some not so much infill, but I got some problems, yeah. But I would say like 1 or 2 kilos, maybe 3 kilos, 3 spools of non-useful parts, something like that. I'm pretty proud of not so much waste on this project.
Right. And I think that's one of the good things about 3D printing as well, because when you're using that method of manufacturing, you're really only using the amount of material that you need, right, per print. So it looks like you printed these parts, you attached them. It looks like you used some metal staples to attach them to each other. How did you attach it then to the frame, to the wooden frame?
Good question. That's why I will put a zoom on my SolidWorks. That's why I designed this kind of an angle, like a 90 degrees angle, because I was thinking about that, as you say, like, okay, between each other, we can use like hot staples or just fuse the material together. But what about put it into the wood, right? So I just created this 90 degrees angle, as you can see, and this goes all along the banana part that I call. And yes, because it was plastic, I just drilled some holes. I could design the holes, but it doesn't really matter sometimes, because if you can drill it and it's going to be easier and faster than just trying to design everything all along this. So that was the technique that I used. But then again, the challenge was the wood behavior, because as I said, sometimes we're not the same distance between this face and this face than the following one, because different thickness, the wood, it's flexible. But then again, I learned a lot of working with CNC parts, plywood parts, and I will do it again, definitely, because I learned a lot with this project.
That's interesting. So imperfections in the wood made it a bit more challenging because the spaces between all of these bananas, as you call
Exactly.
them, were not the same.
Exactly.
Very cool. Awesome. All right. So now you've 3D printed 400 parts. You've covered, is that 400 parts for the top and bottom?
Yeah, exactly.
Okay. So you've covered the top and bottom. Now, what came after that? Are we getting closer to the finishing step? I'm really curious about how you got that finish on the Pokeball to make it a shiny. It almost looks like a car. It's so
Yeah,
shiny.
so this was the final design. One question that I had is like, how did you design this? And a lot of people that are familiarized, I mean, we are in SolidWorks family, so I can speak like very technique
Sure.
situation. It's like this part, it's indeed a part. I use multi-body design this thing, because I didn't want to have like a lot of parts involved and doing an assembly.
I see.
After that,
Okay.
to simulate the hinges, I did an assembly. For me, it was the good choice. Don't ask me why, but I know that people doesn't really use sometimes like multi-body parts. You can do it, and here's the, um, the proof. But anyway, we have the hinge system, right? So
Oh, wow.
this is
That
what I
looks
designed
amazing.
at the end of the day. I wanted to be a project that not just me will enjoy, right? It was like kind of multi-generational project, like father and son, or mom and daughter, or family coming to see this Pokeball. So that's why I just create like an environment for people to go inside. And I said, like, why not trying to go old school? And I just bought an old TV, a video game console that reminds me my childhood. And this was we will say the final, or the projection that I have for this. And let me tell you that at the beginning I was trying to cut it in half, right? Because a Pokeball, and I don't know if everyone noticed, it doesn't open really in half, right? You have like a castor kind of teeth or something going here, right? I call it the door. And a lot of people ask me like, why did you did this, right? So the thing is that this is almost 2 meters wide and tall. Um, and because I wanted to invite people to go inside, not only me, it's like I don't see people jumping 1 meter
Right.
to go inside. So I just decided to design this kind of door thing, and that's why when you see the main part, you have like an
It's like a little
space.
doorway.
Exactly.
So you tried to account for safety as well when designing this, so people wouldn't have to jump over
Yeah,
that
exactly.
wall.
I want to be comfortable and like something that you can go inside, because like this is easier, right? But this was a technical challenge. It was not so easy, to be
Yeah,
honest.
I would imagine so.
To
Eh,
produce this, this is not the final design. At first, I was thinking to 3D print a part like this,
mhm.
like big enough to go inside. But imagine just having this part out of plastic. It will break like in a couple of openings and
Right.
close. So that's why I decided to we'll say like harden this thing or make it more stable with some wood. Let me show you if I do my job really well. I think I have there we go, something like this. There we go.
So another multi-body technique for the door, is that right?
Exactly. And I went back to the CNC shop, and I just cut these like supports, the red ones, as you can see.
Hmm.
It helped me as a guide, and also it helped me to solidify the door. Um, it was it was very complicated. We spent like 1 week and a half with one friend of mine trying to align everything, because as you can see here, we almost don't have any tolerances at all.
Right.
Uh, but yeah, it was a pretty good challenge. But hey, we have it, and we're
And it looks
proud.
amazing. Yeah, and multi-body is the answer to everything, as we're hearing in the chat,
Oh
which
yeah,
I agree with.
nice one.
I also
Thank
like
you.
it looks like you have this figure of a man that you used to plan out, actually walking in this Pokeball. Did you model that yourself, or was that an asset you found elsewhere?
No, I found it elsewhere, and this is also important for people that are designing. Like, if you want to have some assets, you can just go to the 3D community, makers community. We have in SolidWorks 3D Experience. If you know a little bit about that, people that I know that you know, but people who doesn't know,
Yeah,
you can go and you have a lot of resources over there. You can find a lot of things, or you can just ask if like somebody have in assets, and they will share it for free. And this is amazing, because I just save a lot of time on this modeling, because I said to myself, like, I just wanted to look pretty, but I don't want to model myself.
right. Yeah, and that's a great point too. Definitely shout out to the Made in 3D community on the 3D Experience platform. I know you've posted there, Carlos. I've posted a bunch of models there. A great place to just connect with fellow designers. And as you did in this case, save yourself work by not having to remodel an entire human body. This is perfect for this use
Exactly,
case. Great.
exactly. So I don't know what it's next. What do you think, Noah? Maybe we can just answer some questions.
We could, well, I'm actually kind of curious because I watched your video on YouTube and it looked like you also collaborated with some other designers
Yeah,
for this Pokeball. It looks like you had someone make a carpet, you had someone make other Pokemon assets. So this was very much a community driven project. Is that right?
yeah. Thank you to share this with the community. I'm pretty proud of this, because at the beginning of the project, I was teasing this. Even I was in UK beginning of the year, and I was speaking with people, and it was funny because a lot of people told me like, you are crazy and you are not going to do it. It's impossible, and
Yeah.
things like that, right? But once that I had the structure, the first structure of the project, people started to notice, and a lot of friend of mine or people that I barely knew because of the social media. They reached me out and they were like, "I want to be part of this. This is amazing. It's like one of a kind, right?" And I was like, "For sure." And they were passionate as me, and this is the beauty of this kind of projects and the maker community, as you said. This is why you don't need to be afraid to don't be to be afraid to share your work, even if it's a small one. It doesn't mean to be like a bigger one, but people will give you some tips or trying to work with you. And this was the case on this project. So I had a friend of mine who do some tufting, it's called, and he made a custom rug for the interior, because again I was thinking like, what are we going to put inside of here? So it was pretty complicated to have a custom made rug on the inside. So he managed to do that. Also, we had some decorations that another friend was making with some Pokemon cards. So some artistic way to express the creation and the love that we have to create and to share with people. So I'm pretty grateful, and I'm pretty happy that this was not a one-man project, and this is one of the things I want to really highlight on this project. If I was all alone, this is not possible. This was possible because people loving to create, and I want to thank a lot of people. I will spend like 1 hour thanking a lot of people, because this is the backstage of the bill, right? Like my wife, my friends, SolidWorks as well. Also, when I teased the project to SolidWorks, they were like, "You are a crazy man, but let's go." And that's excited
Right.
about this, and the SolidWorks community is just amazing, and I'm pretty happy to be part of the SolidWorks family.
And we're happy you're part of it too. And I can imagine that too. When you first tell people you want to make this, they're like, "What? That sounds crazy." But once you actually started making the frame and people started seeing it come to life, they're like, "Okay, how can I get involved?" Which
Exactly.
is really cool.
I
So
think, yeah.
yeah,
Sorry, go ahead.
I just want to know, because now that we're seeing the full assembly here in SolidWorks working and everything, can you tell us how many parts you created in SolidWorks to visualize this?
Oof, nice one. Let me check real quick. So the feature tree, as you can see, is
Yeah.
it's
Yep.
wow.
That's
It goes, it goes, it goes, it goes, it goes. I don't know how can we check that.
wow.
We have I did folders, because at the end of the day we had a lot of parts. I don't know if we have
Oh, so
parts.
you organize them into folders.
Yeah, exactly. Like that,
Okay.
it will be like, for example, if I want to pop in the interiors, let's put it, and we have all the interiors. And also, if I don't want to see the upper half, we can just hide it, right? So this is better to explain, and also it's for me was like I just had my laptop at the workshop and just checking like, okay, this is the way to go, which part goes to which one, and things like that. But about the bodies, we have like 36, 12, something like you. What do you want? Like maybe 100 things like that,
Maybe 100.
100 and
Wow.
something. Okay, see, I see the one comment, 164 solid ports, 164.
164 solid bodies. Okay, so not a small assembly.
Yeah, and this was not even an assembly; it was like the multi-body part.
That's right. And we got
And
a question as well. How many delete or move faces are in that feature tree?
whoa, a
We won't
couple of
make you
them.
count, but there's got to be a ton.
Yeah, uh, I would say shame on me, but maybe not, because these are some features that maybe people, and also look, I have a a non-defined function or a problem here, but I think this is the beauty of the 3D modeling and the real thing and situation. And this is one thing that I want to share with everyone, because when I was in engineer school, we are taught that don't break the mold, right? Like just trying to follow the rules and the design. When you are creating projects like this, you can go ahead and do it whatever you want. And if you want to move some phase or delete some phase or have an error here and there, that's the beauty of the imperfection, right? I'm not saying that if you are going to design a plane or to 3D model a plane, please do it the right way. But when you are creating some maker stuff, just if you have the final result and you are happy with it, just go ahead.
Yeah. And if you had to, because I'd imagine this was just a ton of design work and just a lot of practice in that exercise of CAD modeling, what would you say was maybe your top command or maybe your top two commands that you use the most when creating this assembly?
Nice question as well. For this one, for this project was a lot of patterns, circular patterns. Also to create the slots, I just create, I don't remember the name. It was a pattern, but it was like a driven one, I think.
Driven pattern.
Driven pattern, yeah. Also, I did a lot of revolve, as you can see.
Yeah.
Also, because of the cut, let's see if we can. Maybe it's not cut revolve.
I would also probably say the mirror command too, so you didn't have to model all of this twice.
Yeah, a lot of that was involved. I tried to use some 3D sketch at one point. I mean, I don't think I'm going to find it. Let's give it some couple of seconds, maybe here.
And we have a comment as well. Subfolders in the bodies folder is chef's kiss. That's a great tip that you shared with us,
Thanks.
Carlos. Subfolders are definitely the way to go when you're creating large assemblies like this.
Thanks. Well, as you can see, I cannot find it, but you can imagine, like, sometimes I was just designing some things and didn't work the way I wanted to, or it was flat or things like that. And I know that you can go with surface or things like that, but I was trying to speed up the CAD because I knew that there was a lot of work to do on the big thing we have over there. And yeah, I think the tools that I used the most was repetition, pattern, revolve, mirror. This is the important to define your origin, right? I'm coming back to school, but origin is the master on this kind of builds.
Definitely. That's great. And let's see, we also have, first off, all these files, are they available? Are you sharing these with the community?
Good question. Maybe I will. Let's do something. I will share the whole structure on the blog, Makers Community blog. So maybe we can put the link, and I will share him there. Yeah, if people are interested on going this way, why not? Maybe it will be useful for people to do a smaller version, an improving one. I was thinking to make a version 2 for kids only, because like that will be way smaller, and I will just improve about all my mistakes that I made. I don't know if we can show. I think I prepared like how much post-processing was involved on this build, and trust me, I don't want to go again on this process. So I think doing it smaller will be better. As you can see, I use a lot of different colors of filaments because at the end of the day, it doesn't matter. So we use fiberglass and resin and a lot of putty to cover the imperfections. I was really tired, as you can see, by the end of the day. And the funny part about the putty is that I use almost 10 kilos, and 90% of it was sanded down because The only thing that you want is to have like smooth surface to apply the primer and the paint. And it was weeks and weeks and weeks of hard work. Yeah, as you can see as well, I'm doing the paint job on the interiors. It was relaxing. It was funny. It was great. I will do it again, maybe. I don't know, because you just put your music and you are creating on your garage, and
Mhm.
if you want, you can invite your son or your daughter to help you out, and it can be a pretty good project, a family one. So I don't know. I'm just making this kind of stuff. People ask me a lot of times, like, why? The first one is why
Right.
not, and the second one is like, I'm just trying to push and to inspire people to go ahead and to tell, like, there is no possible impossibles. It will take time, but if you are committed and you have the will, you will you will do it.
Mhm. That's right. As someone pointed out in the chat, if you know how to use this software, there is no limit for you, which is well
Exactly.
said. And it was so interesting to see that process using all the putty, using the primer, then the paint, then the finish. How long did that process take you? That was a month long, several weeks?
The thing, this is one of the things I didn't want to use 3D printing, because I know 3D printing very well. So this is one of the things that I want to use, like CNC. So as you
Okay.
can, as I was talking about that earlier, I tried to bend some wood to make it brown. But I just remember that day when it didn't work. It was like, wow, we need to find a solution. And then when I just saw the opportunity to use 3D printing, I knew right away that a lot of post processing will be involved,
Hmm.
uh, because you need to sand everything, and in order to be shiny enough, well, there is a lot of post processing involved. The good thing about this project is, like, because it was a giant sphere, sanding it down was not so quite hard, because you can
Hmm.
use a big machine, like a sander, electrical sander, and it was hard because I wanted to be perfect. But
Right.
perfection is never reached, right? But I wanted at least to be beautiful, and this is one of the things that sometimes I was sanding and putting more putty and sanding, and then I was like, I
Right.
don't even know if it was run enough. So I learned a lot of post processing. I
Hmm.
went to YouTube as always, and
Right.
I saw a lot of techniques of people doing cars and that kind of paint job, and I learned a lot. And I spent like maybe 3 or 4 weeks trying to get it like perfect, smooth.
Wow. 3 or 4 weeks.
Yeah, exactly. And it's funny because sometimes I compare it, like, boxers or UFC
Hmm.
preparations. They prepare for months or years, and at the end of the day, the fight or the event, it only lasts a couple of minutes, right?
Right.
So it was the same with this pokeball, because we were like working a lot of time trying to post processing, and we painted in 1 hour or something like that. It was
Wow.
pretty easy to paint, but the preparation was the complicated part.
Yeah, when it comes to painting and getting a flat surface, I'm sure it's all about preparation. And I'd say you definitely succeeded. I could see the shine off of the roof of the Pokeball. It looks incredible. And you
Thanks.
mentioned some other ways that you thought about doing. You thought about bending wood, which was interesting. I thought that when I first saw this, I was like, maybe he did that. We also have a comment in the chat about polyurethane shaping. Was that ever something you thought about?
Yeah, and that's the good question. If you give me 1 second, I'm
Sure.
coming right back.
Yeah. So yeah, let us know in the chat if you think of any other manufacturing methods Carlos could have used, did use.
So
And
this
is
we
that
have the
foam?
yeah, it's polyurethane kind of. I don't know if this is the material that the person who made the comment was thinking about it, but it's like something rigid that you can find for construction here in Europe. And what I was thinking is to do the bananas and then trying to just, as they say, shaping it.
Okay.
But it's not an easy material, and as you can see, when you are working on the sphere, let me just show you real quick. As we said, like if you're trying to, I will just trying to explain really easy. You see the distance between this face and this face, and
Yes.
then you compare it to the one that you have over here, and then you take into account that these have an angle, and every time you go further, the angle change. Well, that complexity, it's too much to handle by a non-numerical kind of fabrication. If the person maybe is thinking about the expensive foam, maybe he was thinking about this. I thought about it. I thought to put something inside of the pokeball, inside of the structure, sorry, and then just spray an expensive foam, and then coming
Right.
to um, to take away all the material. The thing about the expensive foam is that it can be expensive, as you can see the size of the build. So I try to keep low the expenses, because I made a rough calculation, and with one bottle of expensive foam will be enough, not enough to fool the one part of this structure. So at the
I
end of the
see.
day, just imagine one times 25. I think we have here like 25 sections, something like that. I don't remember.
Right. So you would have had to buy 25 bottles of spray foam, which didn't really make sense,
Yeah, 25 for the bottom and 25 for the
and
upper
25 for
part,
the top. Wow.
right? So that was the thing. And yeah, but this is the, and thank you for participating, all the people in the comments, and but this is the beauty of it. Like, try to solve this problem. Like, okay, let's do this, let's do that, and let's try it, and make some mistakes. That's normal.
Right. Yeah, that's what it's all about, right? Finding 5 different ways that don't work before you finally find one that does.
Exactly.
And it also looks like you added a base as well. You put some wheels on the bottom. Is that turf that you added in on the actual product?
Yeah, and this is a nice one. Let me show you, because at the end of the day, we have this center part that make something like a sandwich. I know that I have like definition for everything, right? Like banana sandwich, but
Right.
for me, it helps me visualize how the assembly will work. And as you can see, we have the sandwich, and this is very interesting, because if people will see why I did like a bigger circle, will understand that I don't did quite well my engineering job. So the surface here that was supporting the whole sphere was not big enough. So when I went inside, the sphere did what a sphere does. It began to roll.
Oh
Be-
no.
yeah, because the surface of support with the floor was not big enough. I just remember one day I was almost rolling over, and I was really afraid, because we were pretty advanced on the work. We were saying like, this will be a danger for people. So that's why we decided to cut again a CNC bigger base, and this helped a lot to, we'll say, to have an even surface, and to equilibrate, to have some balance to the whole assembly. In order to you don't see this mistake, I put some grass on it. So I'm happy to share this, because there are interesting mistakes. This is the real world, and we are not perfect. And even building this kind of things, I would love to people learn from the mistakes that I made. Maybe some people will say like, yeah, it makes sense. Like, obviously, right? If you don't have enough support, if you go inside, it will try to roll over, right? But
Yeah.
hey, I wasn't thinking clearly. But then again, I'm
No,
just
that's a part of the process. As we see in the chat, center of mass came in. Definitely have to account for that. And honestly, it looks great. I wouldn't have even known that it wasn't a part of your original design. So
thanks.
it looks really good.
Maybe I should keep the secret.
Yeah. I am curious though, because that piece of plywood is supporting a lot of weight. I'd imagine this thing is quite heavy. How much did it came out to weigh?
Sorry again.
How much does it weigh?
Oh, the whole build.
Yeah.
Well, it's almost 100 kilos. I don't remember quite well the pounds.
100 kilos.
200 pounds.
Yeah,
more.
it's over 200 pounds.
Yeah, easily.
Wow.
That was another thing that I want to share. Thing about doors, because we were building this on a garage and we were pretty happy. And this was a 2-person job with one good friend of mine that always followed me with this crazy stuff. And we were building it. And then when we have the whole structure, and we were pretty happy. We were like, what happens if it doesn't fit the door of your studio? And I was like, good question. I never thought about it. So fortunately enough, I have a big door, not so big, but big enough to split in half this build and make it go through the door. But even transportation was a challenge. I mean, I could make like videos about this build because it was like a multi-phase project. You have the build, but then you have the transportation, and then you have the improvements. And as I said, I will share these files, and I would love to see what people can do with this. And I would love to see improvements. Also, I was thinking about putting like electrical cylinders to open and close
So
the
it opens
Pokeball.
automatically.
Exactly.
That would be cool.
Yeah, maybe put some people told me like, why not to make this center part like transparent, like that people can go inside and say hello and take a photo and say, hey, I'm inside a Pokeball. And I was like, yeah, that's a good idea. But yeah, I mean, that's the beauty of it.
I love that. I love those ideas. Let us know in the chat if you have any ways that you think you can manage to make this Pokeball even cooler, if it's even possible, because it looks so awesome as
There's
is.
a lot of improvements.
Yeah. I do want to come back to that question we asked earlier. We had some guesses in the chat: 4,000, 2,000, 1,000. What was roughly the cost that it took to make this?
Without labor,
without labor.
Without labor, we are around 2,500 US dollars.
So pretty good guesses.
Yeah, they were pretty good. We need to count the CNC parts because I don't have a bigger machine. I needed to how to say that, to buy the services. I don't have the word in English. Like outsource the cutting. The cutting. Also, we have the filaments, of course. We have the potty. We use around 10 kilos of potty. We use also fiberglass. We use paint. Also, it's not so much, but it adds. We bought the Null TV, the video game console, and yeah, a lot of tests with the foam that I show you.
Gotcha.
So yeah, more or less 2,500, and if people are interested in how long or how much labor, counting on hours, speaking in hours, I just calculated roughly it was like 600 hours. So we
Wow.
spent 4 months, and the last month was like nonstop, like Monday through Sunday. And yeah, I'm pretty happy to show you the final result. Uh,
Wow,
we were
look at that.
I remember that day we were pretty tired, but almost like a tear was rolling on my face, because I was like, we made it, man. Like, whoa.
It's like your child at this point.
Exactly. And as you
Yeah.
can see, you can open it. It's a little bit heavy. But yeah, we went through a lot of things, a lot of learning. Sometimes I go inside just to cut out of the actual world, and to go
Right.
back go back on my childhood, and to
Hmm.
play some old video games, and just remember the old days. Like, you only had that, or you don't have any telephone, and you are living the dream of being inside of a pokeball.
That's right.
Uh,
It's the perfect
that,
getaway.
exactly. So anyone who wants to visit the pokeball, I'm completely okay with that. Just come, send a message. I'm in France. Maybe it's too far away, but who knows? I'm just pretty happy to share this with the world. And it's not mine. This is for all the people who believe, who are dreamers, who are makers. And, and I'm crazy man, but we need to do that.
It may be crazy, but all the time, all the effort was so worth it. It looks incredible, Carlos. Thank you so much for sharing, your whole process with us, with the chat, with the channel. We're so happy that you could join us. Any last parting words that you want to leave us with today?
Well, as I said, there is no impossibles if you have the will, if you have the tools. Right now, we are living in a wonderful era of 3D modeling, 3D manufacturing. You can do small things, big things. So please come join the adventure. And also, I want to invite everyone who are in Houston. I will be in Houston for 3D Experience World, amazing event that is going to happen in February, and I'm pretty excited to be there. I will be hanging around, and answer some question, and also I will be challenging Noah Sif for a coffee 3D printing challenge, because coffee is one of the things that we love at World. And Noah, I think, and I hope you are ready for this challenge.
The
Uh,
challenge is accepted. And that goes for anyone else in the chat as well. If you're going to join us in Houston at 3D Experience World, bring your best coffee creation, and we'll have a little competition. We'll have some fun. But thank you again, Carlos. Again, that's Carlos 3D on YouTube. Check out his channel. He's not just done this project, but tons more incredible makes. And again, thank you so much for having us. Thank you to the chat. And we hope to see you at 3D Experience World next year.
I will be there. Thank you for having me, and let's meet.
All right. Thanks, everyone.
Ciao, ciao.